In this short video, we'll talk a little bit about some of the research practices we should be aware of. So some of the things you learn in grad school, you have to take a lot of research methods and statistics classes. In those classes, you learn what the right statistical techniques are to run, and you learn a set of rules on how to collect and analyze data. At the same time, your other professors and sometimes your advisors will teach you some of these bad research habits. This most of the time is not malicious at all. It's almost always the product of how they were taught when they were in graduate school. They fall victim to some of the things we talked about in our previous video. So my first piece of advice is to listen to your statistics teachers. They will give you a roadmap on how to properly explore your data and will make sure that you're aware when you're doing something wrong. And don't just take the advice of one person only. Don't even take my word alone for it. Talk to as many people as you can about how to do research, and you'll get a stronger sense of what you're doing, what other people are doing, and what is the right way to proceed. There are a ton of questionable research practices, and they're all really easy to do. You can have a lot of dependent variables and only report one of them. You could have multiple experimental conditions and hide some of them at the end. Or you can run 4 or 5 total experiments and only present the ones that worked. This goes hand in hand with the file drawer effect that we've talked about. Another thing is peeking at your data. If you aren't done with your experiment, but you've already found a significant effect, you stop your experiment prematurely. Alternatively, if you've completed your experiment and your results just aren't quite there yet, you would just run a few more people just to get you over the line. You could add a few more people, or you could drop a few people to help you kind of get the result that you want. And then there are things like harking, which we've touched on. All these practices are wrong, and you should definitely never do them. The thing that is so hard, though, is that it's really tough to tell which studies have been properly run and which studies have been using questionable research practices by just reading the final product. And this can be a little scary to think about, especially with the pressures that some academics face about the need to publish a lot of papers. Okay, you can just also straight up falsify your data. Now, this one is easy to try, but it's hard to do well, kind of like counterfeiting money. In general, these types of tactics or techniques that manipulate your overall conclusions of the paper is referred to as p-hacking. P-hacking was commonplace back in the day, but ever since the replication crisis, we have really become aware that these practices have no place in research. So you can start with being aware of them yourselves and making a commitment to doing research the right way, and also only associating yourself with collaborators who do the same. You should make a plan before collecting your data. So an a priori pre-specified plan. You set in stone what you want to test, and then you test it. We've learned that running too many tests and doing that over things that we didn't predict can be bad, and this can inflate things like type 1 errors. But that doesn't mean that unplanned analyses are inherently evil. They are only evil when you run a bunch of tests and only show the ones that work and pretend all along like those were the only tests you were running in the first place. But it's totally fine to run unplanned or exploratory analyses. You just have to be honest about it and disclose that in your paper. And it's as easy as saying something like, in an exploratory analysis, we compared so-and-so. Science is also getting better in the fact that it's more open and transparent these days. There are whole organizations such as the Center for Open Science that are dedicated to this. And the Open Science Framework, which is actually a part of the Center for Open Science, is a website that researchers can use to upload materials and data to share with other researchers. Nowadays, a lot of journals actually require that you post your data online somewhere. So you post your data, your experimental materials, and your analysis code online for everyone to freely view and download. Another great thing that's kind of gained traction over the past few years is pre-registration. Pre-registration is where you specify your hypothesis, your proposed methods, and your plan for what you're going to analyze before you even run your experiment. After you specify this, you upload a time-stamped version that you cannot change to the Open Science Framework. That way, this helps to fight against things like harking, multiple comparisons, and p-hacking because you've already laid out what exactly you're testing. You can't go back and change it. There are other sites that do this kind of thing besides OSF, but this is definitely a popular choice. There are also other incentives for open science that journals are doing. Some journals will give your experiment special badges for posting your data and materials online. And more journals these days are offering what are known as pre-registered studies. Traditionally, you would run your experiment, analyze your data, write up your paper, and submit the final product for publication. But with pre-registered studies, you actually submit your paper before you even do it. So you write your introduction section and your proposed methods, and the journal agrees based on your rationale whether or not they want to publish it, regardless on how the experiment turns out. So it could be a total failure and it would still be publishable. So now you have pre-registration that helps to fight things like p-hacking, and pre-registered studies that help to fight against things like publication bias. These are huge steps for our field to take and will help to give us more confidence in research. But research is still a slow process and it will take some time for more journals to start adopting these good types of research practices. One last thing we should talk about is retraction. Retractions are when an author or a journal withdraws their support for the findings of a paper because they aren't trustworthy. If you have ever come across a retracted paper, just make sure to not use that paper in your own research. While disputed findings can still remain in the literature, retracted studies are usually seriously flawed. It's important to try and keep up to date with what studies have been retracted or not. Retractionwatch.org is a great site for you all to be aware of as researchers and helps define and detail newly retracted studies. Okay, so that's it for this video, and we'll see you next time.